Assalamu alaikum. So, to be honest, right, I usually don't create videos like this to explain. But looking at this question, I really see the potential of having fun with it. So, thank you so much to one of my fellow friends, to one of my friends, which is Azri, for sharing this question. He already has a solution, but I would like to explain it deeply. Now, this is basically the first chapter from 5 at maths, okay? So basically, the question given stated that fragments of ceramics over 200 years old were discovered at an archaeological site. The diagram below shows a segment of circle representing the fragment of ceramics discovered. Okay, so basically they found something underground and trying to find a measurement. So they sketch a really good diagram, but remember we can't just say that this diagram is a circle or a semicircle. Sorry, semicircle. It's not a semicircle. Anyway, using the information given showed that the formula used to determine the radius of the circle is as follows. So basically they gave us this shape. Now the question didn't mention anything regarding P is the diameter nor X is the radius. Therefore, we can't say, oh, this is a semicircle. No, it's not a semicircle. In fact, it's just a segment of circle. So let's try and solve it by deriving a formula, which is our R is our subject. Our R is the subject in terms of P and X. Okay. So as far as I know, this question should inform us that this length of the segment circle are similar if divided by 2. Anyway, the same lengths, but okay, no problem. So first we have to derive a formula, which is the radius is equal to in terms of P and X. So we have this shape, right? So let's draw it. A really, a really simple segment of circle here. So basically, this is not a semicircle, so it's okay. So let's say this is our P here. Our P now X. Let's draw a complete semicircle so we have a better look of it. So by that means I have to use another color to present this other incomplete part, the semicircle. Alright. So now we have a complete version of a semicircle. Now, why is it important, you ask? Because we want to find the radius, and the radius is the distance between the center of the circle and the circumference. So let's find it. This is our it should be different colors. So should use another one. Let me use a green color. We know this is a radius. Okay, I'm gonna use this dot here to represent the center of the circle. Now I will draw another one. Okay, let me make it better. Yes, this is a radius, and this I don't know. This, in fact, is the other radius. Okay, so now we have a strategy because as you can see over here, right? Let's use another color, blue. As you can see over here, all right, or this shade region here, it looks like a right angle triangle. So let's draw one. Let's extract the information and put it here. Yes, over here. Make it better. So this will be our right angle triangle. And we will have our base here. And our base is half the length of P. So it should be P over 2. How about our hypotenuse? That will be our radius. Because remember, the distance between the circumference of the circle and the center of the circle is always the same around the circle, no matter what, no matter which, as long as it's center of the circle, the length will always be the same. So P over 2, how about our height of the triangle? Now we know that this, okay, let me draw a point over here. Let's say this point, let's call it A. So at point A is our length, which is x, but the green line shows the length of r. So how do we get A to the center, the length of A to the center of the semicircle, which is r minus x? Really simple. There we go. Now, as we can see, another step is whenever there is a right angle triangle, we could use the Pythagoras theorem, which is a squared plus b squared is equal to c squared. Both sides of the triangle squared each of the term, you will get, by adding them together, we will get the length of the longest triangle, the square of it. So let's say our sides. Any a could be p over 2, so p over 2 square plus r minus x square is equal to our longest side of the triangle should be r square. All we have to do is just expand the brackets. Therefore, we'll get p square over 4 plus r square minus 2rx plus x square is equal to r square. Now, right now, let's take away r square both sides. So you get p square over 4 minus 2rx plus x squared is equal to 0. Now, we want to derive the formula r in terms of p and x. So any terms that has the variable r should be in one side of the equation. So let's add 2rx both sides. We will get p squared over 4 plus x squared is equal to 2rx. Okay, so let's continue the working here. More space. So we want r, only r, because we are deriving a formula r in terms of p and x, or we are expressing an equation in terms of p and x. Okay, so let's divide both sides with 2x. Divide both sides with 2x. P squared over 4 plus x squared over 2rx. All right. So, oh shoot, it's 2x. Sorry, 2x. So right now we can simplify both expressions in the equation, or both terms. We will get r is equal to, should be p squared over 8x and x over 2. If you want to leave it like this, you may, but the question wants us to prove in that form. Therefore, we should do it all together until we will get in that form. So by combining these two fractions, we will get a single fraction by multiplying 4x over 2. Therefore, it should be p squared plus 4x squared over 8x. Is it the same? Yes, it is. So that is how we derive the formula in terms of p and x. Now, the second question asks if the values of x and p are 2 centimeters and 6 centimeters respectively, meaning that x should be 2 and p should be 6. So basically, our second question asks if x is 2 centimeters and our p is 6 centimeters, determine the central angle subtended by the segment in radians. Basically, if we redraw this segment circle like this. Now let me take the original. No. Let's just make a new one like this. Without p. Wait, let me just do this. Alright, this is a segment circle. Okay, it's not a semicircle. It's a segment circle. So basically, let's say the center is here, right? So we have to find the angle. That's the angle that we are looking for. But the question is, how do we find it? Now, if you recall, just now we did the triangle, right? Which is this. This is the triangle that we are talking about. So let's redraw the triangle once again. Redraw it. Remember, this triangle is the same triangle that we did before. Okay? So right now, we know that we are taking half of the angle, therefore this should be theta over 2. Originally, it will be theta, but since we are dividing by 2, it will be theta over 2. And we know our hypotenuse is the radius, and the radius should be... we haven't found the radius yet, so let's find the radius first. So r is equal to p squared plus 4x squared over 8x. So let's substitute the values given. 6 squared should be 36 plus 4 times 4, 16 over 16. And that should be 52 over 16. 52 over 16 centimeters. All right. If you want to simplify it, we can. I think. Let me use my calculator. We will get 13 over 4, or in decimal form, if you prefer, 3.25 centimeters. So this is our radius. So basically, this should be 3.25 centimeters. Now P should be 3 centimeters. Or if you want to find the height of the triangle, no problem. It's your way. Anyway, as long as you can get the angle of the subtended angle that is connected to the center of the circle. Alright, so if you want to use the formula, you may, but no, I'm still going to use the old-fashioned way. We will convert the degree in angles in degree to radians. So let's find the angle first. So let's say theta over 2 should be alpha before we divide by 2. So I'm sorry, it's a alpha, yes. Let's use alpha. So alpha is equal to theta. So we will use in this situation. So this is the acronym, which I would say sine alpha is equal to opposite over hypotenuse. So what is the value? Remember the opposite value should be like this, the opposite of the angle. And this will be our hypotenuse. Okay, so always the longest side of the triangle. So opposite value should be 3, while our hypotenuse value should be 3.25. So what will be our angle? Well, it should be 3 over 3.25, so it should be 67.38 degrees. Now we want to find theta, which is the angle that we want to find. So we know that theta over 2 is equivalent to alpha, and we know alpha is equal to 67.38 degrees. By multiplying both sides with 2, we will get theta is equal to 134.76 degrees. Now, if you want to convert this to radian, the formula should be theta. Let me remember theta. There's theta times pi over 180 degrees. So our theta should be 134.76 times pi over 180 degrees. So this should give us 2.35 radian, or rad, the unit of it. So, well, I got the answer. Now I want to check whether or not is it correct or incorrect. It should be 2.35. I'll recommend using more decimal points, but it depends. If you want to take more decimal points, then you may. Okay. I think that is all for now. Thank you so much for watching this video, and I'll see you later. Assalamu alaikum.